Hey everyone, welcome back to John Codes. This is part 2 of my Kubernetes for Beginners series. In this video, we'll be talking about deploying a Kubernetes cluster. So make sure to like, comment, and subscribe, and also join the Discord if you have any questions. So let's go. Now, before we can really get into it, we need to make sure we have a few necessary tools installed. So first, we need to make sure we have Docker installed. And here I'm on the Docker docs page where we can get instructions for installing on Mac, Windows, Linux. I'll put a link to this in the description so that you can follow the install instructions for Docker there. Now, once you have that installed in your toolbar or in your processes manager, you should have some indication that Docker desktop is running. And I can click on that here and see that that is running on my Mac. Next, we need to make sure that we have the kube command line tool installed, or more affectionately called kubectl. And we can install that with brew on Mac here, or there's instructions here on the Kubernetes docs homepage for installing kubectl. So let's head over to our terminal, and we can brew install kubectl. And once that's finished installing, we can kubectl, and we should see a whole list of commands that we can run on the terminal here. And next we need to install something called kind, which stands for Kubernetes in Docker. This is a great little tool that we can use to have clusters deployed on our local machine right in Docker, where Docker images are represented as the nodes of the cluster. We can install it super easily with brew install kind. And I'll put links for all these in the description. There's all kinds of different ways to install them. And once kind is installed, we can simply invoke kind and get the help message there and see that it's installed. Now, when you deploy Kubernetes, the end result is a cluster. And a Kubernetes cluster is made up of several worker node machines that end up running the orchestrated workflows. So this cluster has several nodes, and typically nodes are virtual machines. But really, these nodes could be any kind of computer, a bare metal server, or anything. Now, the worker nodes are managed by the cluster control plane, which is typically another virtual machine of some kind. The control plane exposes necessary Kubernetes APIs that really are responsible for orchestrating the entire cluster, making objects available, really everything. Now, the control plane is made up of several components, most of which we won't get into today. It's a bit out of scope for this video. But what you need to know about the control plane is that it is the manager for the entire cluster, and 2, it exposes the API server, which is very important to enable Kubernetes objects to be available and really for the entire orchestration to work. Now, worker nodes have a container runtime, like Docker, a proxy that enables a lot of networking features to happen, and a kubelet, which is an important component to enable nodes to communicate with the control plane. Now, Docker is important because it enables nodes to run pods. And pods are essentially running container runtime configurations. Now, there could be many pods per node, and the pod runtime configurations may actually contain many containers. So the most important thing to remember here is that pods are really the smallest digestible unit of work that a Kubernetes cluster can have. Pods are essentially just configurations of containers where there may be multiple containers within a pod. More typically, a pod will contain one container and be a very small digestible segment of work that is happening. So really what we end up with here is an entire cluster managed by the control plane where it exposes the Kubernetes API to the nodes and the node machines. And there may be any number of the node machines managed by the control plane. And nodes have pods. And these pods have containers. And the containers are where our workloads and apps are actually happening and the compute time is getting used up. So now that we know what a cluster is and what a cluster is made up of, how do you actually get a cluster? There are a bunch of different ways to get a running production cluster, like Google GKE, but it's also really easy and faster and cheaper to get a local development cluster on your workstation. That's where Kind comes into play. So Kind is a tool that creates Kubernetes clusters within Docker, where Docker images are the nodes instead of spinning up full virtual machines. There are a number of really good solutions to this. Another one is called Minikube, and Minikube lets you deploy a cluster right on your machine using more virtualized technology. Now, it's important to note that these local environments like Kind and Minikube are really close to a production-ready Kubernetes cluster, but there may be some small differences, especially with networking and load balancing. So usually it's best practice to deploy your code in an end-to-end test fashion to a production-ready cluster like GKE. Now that we have Kind installed, we can Kind create cluster. And this will create the default cluster Kind, and we'll see that working here in a minute. Great, so this finished installing our Kind cluster, and we can see a command here, a kubectl command, to get the context for the Kind cluster. So let's just paste that in there. Kubectl cluster info context kind. And we can see that the control plane is running locally on port 59707, and other services are running locally as well. When you first install a Kind cluster, Kind will automatically point kubectl directly at the Kind cluster. So if we do kubectl config get contexts, we can see that I have one context installed, the Kind cluster, and that it is our current cluster. Now, kubectl can be configured to point to multiple clusters where you can switch back and forth, but if this is your first time with your first cluster, you should be able to just automatically get the Kind cluster after you install it. So now that we have a cluster, and now that kubectl has been configured to point to that cluster, let's see what we have. So we can do a command kubectl get pods -a, capital A, and that indicates all pods. We can see we have a number of running pods here. They've been running for about 3 minutes, and these are all in the kube system namespace, where these are just basic services that Kubernetes provides to the cluster itself. Now, a namespace is a divisible part of work where you could move about your application. You could say something like, namespace my application or namespace some service. Let's go ahead and create a namespace to see that. So we can do kubectl create namespace my application. And we have namespace / my application created. So we can say kubectl -n for namespace my application get pods. And there's nothing in this namespace right now since we haven't actually deployed anything to this namespace. Now that should give you a little taste of some of the objects that Kubernetes uses. A namespace in itself is an object being served by the control plane down to the nodes. Now, if you remember from my last video, I talked a lot about declarative features that Kubernetes provides. And a lot of that can be used through YAML files. YAML files you can save, YAML files you can commit. So let's do that same process of creating a namespace, a Kubernetes object, with a YAML file, and then applying that YAML file to create the namespace. So first we need the API version, and we could just say v1, and the kind of thing, and this is going to be a namespace, and the metadata. And we are just going to say the name of that namespace is my other namespace. So this here is our declarative way of saying we need a namespace and we need it to be called my other namespace. So let's save that, and we can kubectl apply a file namespace.yaml, and we see namespace my other namespace is created. So we can do kubectl get namespaces, and we can see all the namespaces here provided, and my other namespace just created, and it's active 11 seconds ago. So declaring the things and objects we need within the cluster via YAML files is a really powerful way to save state and save what we need, and you can even commit these YAML files, leading to better practices within your organization. Now, let's go back to talking about deploying a production-ready cluster, especially production-ready on the public cloud. If you need something that is going to be publicly accessible to real users or people inside of your organization that need to access this, most of the time you're going to be deploying something on Google GKE, which is Google's Kubernetes engine, or Amazon EKS, which is their Kubernetes service, or if it's an on-premise cluster with something like vSphere, Tanzu Kubernetes Grid. And these are all great solutions for making a production-ready cluster, but a little out of scope for this video, and especially since it would cost you a little bit of money to actually deploy a production-ready Kubernetes Grid. But for this series, working in Kind or Minikube is just fine. It'll give you the basics of what you need to know and understand about clusters. Well, that does it for this video. Thanks for watching. Subscribe for part 3 coming soon, and make sure to like and comment. Join the Discord if you have any questions. I will catch you next time.